These images are real observations, but they are not ordinary snapshots. One apparent hole is full of cold material. A giant hand is a map of X-rays. A tornado ends in a galaxy that is not attached to it. A question mark contains repeated images of the same objects. And the most famous black hole picture does not show the black hole's surface at all. The pixels are evidence. The mistake is assuming they work like a phone camera. 1. Barnard 68. The hole filled with matter Barnard 68 looks like someone erased a piece of the sky. Against a dense field of Milky Way stars, the center is almost perfectly dark. It is not an empty region. It is a compact molecular cloud, a Bach globule, lying in front of the background stars. Dust inside the cloud absorbs and scatters their visible light. The apparent hole is created by material blocking the view. The wavelength comparison gives the game away. In blue and visible bands, the cloud is broad and opaque. Move into longer near-infrared wavelengths and more background stars appear through its outer regions. The cloud also appears smaller because infrared light passes through lower-density dust more effectively. Darkness in an astronomical image can mean absence. Here, it means obstruction. 2. MSH 1552. The hand made from high-energy data, MSH 1552, resembles an enormous blue or purple hand reaching through space. But there are no fingers. Near the base of the apparent palm is a pulsar, a rapidly rotating, strongly magnetized neutron star left by a supernova. It drives a wind of energetic particles, producing a pulsar wind nebula. The surrounding magnetic field and particle flow create the extended structure that our brains organize into a hand. The familiar composite is not natural color human vision. Chandra observations map different X-ray energies into visible colors. IXPE measurements add information about X-ray polarization, which helps trace the magnetic field structure. Infrared data may be layered into the wider field. The image is not fake. It is a visual language for measurements our eyes cannot detect directly. 3. HH 4950. The galaxy at the tornado's tip, the orange-red structure nicknamed the cosmic tornado, is HH 4950. It is shocked gas, and dust produced as a jet from a forming star collides with surrounding material. At its apparent tip sits a blue-centered spiral galaxy. Earlier Spitzer observations saw a fuzzy object there. Webb's higher resolution revealed the spiral structure. The galaxy is not the source of the outflow, and it is not being struck by the nearby jet. It lies far behind HH 4950. From Earth, the two unrelated systems happen to align. Even the tornado shape requires care. The colors combine several infrared filters, and the arcs trace shocked material. Researchers use those arcs to infer the likely direction of an off-frame protostar, while acknowledging that not every feature necessarily belongs to one simple outflow. One frame contains two systems at vastly different distances. 4. The question mark that repeats one galaxy pair, Webb's image of the cluster max J0417, contains a red curve that resembles the top of a question mark. A separate red object appears near the position of the dot. The curve is not a single bent galaxy. A massive foreground galaxy cluster warps spacetime and bends light from a more distant galaxy pair. In this unusual gravitational lensing arrangement, the same pair appears 5 times. Astronomers label the copies A through E. One is mostly hidden by the glare of a foreground cluster galaxy. The question mark shape therefore combines repeated images created by the lens and another object that visually completes the punctuation. Webb detected infrared light. The displayed colors assign visible colors to different infrared filters so researchers and viewers can compare structure. It is one galaxy pair, copied across the image by gravity. 5. M87. The shadow, not the surface, the orange ring around M87 is often called the first picture of a black hole. That description is useful, but incomplete. A black hole emits no light from inside its event horizon. The Event Horizon Telescope observed radio waves at a wavelength of 1.3 millimeters from hot material around the black hole. 8 observatories synchronized their measurements, creating a virtual telescope roughly the size of Earth. Hundreds of terabytes per telescope per day were transported to correlators, combined and converted into images using several reconstruction methods. The bright ring traces radio emission distorted by extreme gravity. The dark center is the black hole's shadow, a region enlarged by light bending and capture. The event horizon itself is smaller than that shadow, So this is not a visible light photograph of a dark surface. It is direct visual evidence reconstructed from synchronized radio observations of the environment closest to the black hole. Astronomy constantly translates. Dust turns matter into darkness. X-rays become visible colors. Distance places unrelated objects on top of one another. Gravity duplicates galaxies. Radio signals from an Earth-sized telescope become an image of a shadow. The translation does not make the observations less real. It tells us what each pixel actually means. Subscribe to Past and Cosmos for the real story hidden inside astronomical images.